Hello everyone, discover MUDT, the new desalination technology presented by Professor Alain Elayi from Scientechnics at the Arab Water Convention in Dubai. In this video, you will see why MUDT is a game changer in the water industry. Here's an excerpt from Professor Alain Elayi's conference.
What is the main problem of desalination? Everybody knows that the main problem of desalination is the cost. Yes, the cost, but in terms of what? We have been discussing for many days about the other aspect of the implication. It is not only the cost in terms of money, it's the cost also in terms of energy and pollution. So, thinking today only in terms of cost is an error. We have to think about the different aspects of desalination, including, of course, the cost, which is a main parameter. So, what did we do to lower the cost, the overall cost? The overall cost, I mean the desalination, but also the other impacts of the desalination. We create MUDT. MUDT is multitask, unconventional desalination technology. Every word has real meaning. Multitask, unconventional desalination technology. This is a new affordable desalination method. What is new in this method? Why? It has some special, very interesting features. Let's go back to, since the invention of flash evaporation in 1860. Okay, researchers tried to make flash evaporation in a reservoir without success. Why? Nobody could do it. Why? Because, okay, people who are familiar with the flash evaporation know this very well, but let's make a simple explanation for that. This is flash evaporation in a reservoir. We create a vacuum here, and what happens if we create a vacuum? The flash evaporation will last for a few seconds and it will stop. But this is true for in MSF, this is true in all situations. People try to change all the parameters, the pressure, the temperature, the motion of water. Nothing was possible. Flash evaporation in a reservoir stops within some seconds, or let's say sometimes it lasts a little bit more, but it stops. Our technology succeeds, and I say since 1860, people were searching this technology since 1860 by realizing continuous flash evaporation in a reservoir. So this is the first time I am disclosing this technology here for you for the first time. Okay, this is the first time somebody say, I am making flash evaporation, continuous flash evaporation in a reservoir. What does that mean? That means that we produce, this is our reservoir, we produce flash evaporation, and flash evaporation will continue as long as we wish. Now, okay, somebody has some doubt? We have many proofs for that. One of the proofs is patent from USA, from China, from India, from Europe, EPO, from Japan, from Australia, and I can continue much more. So we had patent. What does a patent mean? Everybody know here, patent means that it is new. Nobody has done it before. And it means also that it is feasible from the industrial point of view. So this is a technology that is really disrupting. Now, what did we do? Okay. Now, let's imagine that we want to see this, to see experimentally. Can we see this experimentally? Can we see this flash evaporation experimentally? Okay, what we do, we are in a reservoir, so we cannot see the water inside. What we are going to do is to put a window in front, at the level of the water, a small window because a big window cannot withstand this pressure, or it's quite complicated. We put here, the reservoir is closed, we put a window, and we see what's going at the level of the water, and we see what will happen if we do this. Now, did we do it? Yes, we built a unit at engineering school, and we built a big tower, 50 meters. Okay? We put a window at the level. So this is the window, okay? And you are seeing now flash evaporation, continuous flash evaporation in the reservoir for the first time somebody can see. You see, it is a violent flash evaporation, is a violent phenomenon. It's a fantastic phenomenon. And it's taking place continuously. We have other cameras from the inside. Now you see, we have recorded the data from many. We are at 43 degrees, as you see. This water is boiling so violently at 43 degrees, you see, and it is boiling continuously in a reservoir. And this is the first time that anybody can see this. We did flash evaporation in a reservoir. And we plan it theoretically. We put the mathematical model. Everything was sound. We presented for invention, international patent. We obtained the patent. We built the demonstration unit, and we see here the result of the demonstration unit. 43 degrees, we are at 43 degrees. The screen that you have seen records result every second. Okay, this is scientific. So what will happen now? What will happen? It's very, very simple. We have a reservoir, simple reservoir. We have input water. We flash it continuously, and we condense it. Very low CAPEX, at least very low OPEX. Okay, what's the expenditure? Very, very low. Now, this is the simplest situation. If we want, we make automatic process control, and we drive it by artificial intelligence. So we just put water, hot water, it flashes, we condense it. That's why this method is exceptional. Now, if you want to go to the real situation, and this was the discussion of all these days, we need heat without pollution. Can have heat without pollution? Yes, we can have any quantity of heat without pollution. Here are the possibilities. Any power plant will reject a lot of heat. So imagine all the power plant producing electricity, rejecting heat to the atmosphere. Or to the sea. We can take this because we have a very, very efficient, very fantastic system here that will flash this water. So we take the water from power plant. Okay, where else? Any plant that rejects heat. All the country next to the sea have power plant. We just take the heat and we produce desalination. We can use solar heated seawater. Solar heated seawater we can have very, very high efficiency if we just heat the water with the solar energy. We can use geothermal. We can use subsea water. Subsea water is something also very fantastic. Let me tell you just a few words about it. In the subsea, the water is cold. At the surface of the sea, the water is hot. We flash the water. We can flash it. It's very easy for us. We flash the water at the surface of the sea. We take water from the subsea and we condense it. So almost zero pollution. Very, very little pollution. So we just flash Well, this technology is being applied not in this manner. It's being applied very costly. But here we have a system to apply it in very, very efficient manner and in very interesting. One of the countries which is very, very favorable for this kind of subsurface seawater is Oman. Oman has fantastic possibility for subsurface seawater. We can concentrate brine. Why we couldn't? Why we shouldn't concentrate brine? We just send the water, any water. We can even send very, very aggressive water with acid, whatever we want. It will just flash and go away. Okay, so as I said, I will be available. We have plenty things to say, of course, about this new technology. It's a new technology, and 50 minutes is too little to present. Thank you.
Professor Alain Elayi had not enough time to present his whole communication at the Arab Water Convention. Here is the missing part of the communication. The slides corresponding to my presentation are part of the PowerPoint given for projection at the Arab Water Convention. So a sustainable solution to water shortage has to address water cost, energy cost, and climate cost in terms of air pollution and water pollution. Schematically, we have to address OPEX and CAPEX taking into account for each water cost, energy cost, and climate cost. Stakeholders' requirement are priority. We take into account local specificities and multitasking possibilities to optimize the WEC equation. Finally, in order to optimize the stakeholder requirements, we optimize the WEC equation that takes into account 9 parameters: water, energy, climate, for CAPEX and for OPEX, local specificities, and stakeholder requirements. We obtain in this manner the best proposal for stakeholders. Why is our technology sure? Because we follow nuclear standards for the development and realization of our projects, based on scientific formulation and risk assessment, to secure each step of this invention before its realization. This is what has been done so far. We developed the mathematical and technical concepts for the invention of the flash evaporation in a reservoir, and we presented and obtained patents from main industrial countries. With the same logic, we made the conception of the prototype that could realize flash evaporation in a reservoir and obtained very good results. We went far beyond these results because we built a system capable of making flash evaporation in the same reservoir, at any temperature, and the people who handle this kind of technology know how such a possibility is difficult to achieve. We worked with international companies to study the availability of the material that we need and to design the specific equipment that we shall use. For example, one of our future equipment has been designed specifically for one of our subcontractors by an international company. We ended up with an out-of-scale technology. I give you an example of what we can achieve right here in Dubai at about 40 kilometers from this conference place. We can desalinate hundreds of thousands of cubic meters per day using the wasted heat without interfering at all with Jebel Ali desalination plant. With zero air pollution, almost zero water pollution, and also really attractive investment project. Why? In particular because of the very small OPEX of the installation. We can disseminate this possibility to all countries with a seashore. Another very important feature of our technology is its high performance ratio, higher than the other technologies. MUDT is a game-changer technology. All countries can benefit from it. Thank you.